Hi everybody, and welcome to this session on evil and hero Excel functions. I'm Charles Williams, and I've been lucky enough to be an Excel MVP for the last 12 or 13 years. I'm the author of the FastExcel product and co-author with Jan Carroll of Name Manager. But today we're going to talk about functions. So let's start by considering what makes a function evil and what makes a function a hero. Well, evil functions, I think, are, the bad ones. They're the ones that are easy to make mistakes with. They're hard to understand when you look at them, particularly when you look at what somebody else has done with them, and they're hard to use. They're difficult to work out and check whether they're actually getting the answer you want to, and they break easily whenever you change something in Excel. A classic example being you add a column and VLOOKUP stops working. And they're slow, probably because they're volatile or single-threaded. On the other hand, hero functions are pretty much the opposite. They're powerful, they're flexible, they can do lots of things. They're easy to use, easy to understand, easy to check that they've got the right results. They're robust, they don't start breaking when you do silly things like adding columns. And they're fast, because they're multi-threaded and properly written and so on. Of course, functions can be both evil and hero, as we'll see. A little while back, I ran a survey asking people what they thought were Excel's most evil and most heroic functions. And top of the list at that time came get pivot data. Who knew? That was a real surprise. I don't think it's that bad. The one I think's the worst is indirect. And I was glad to see that, pretty much everybody thinks it's an awful function, apart from a couple of people who think it's a hero function. Because there are some things you can do with it that are very hard to do any other way. VLOOKUP is very mixed. Some people like it because it's an easy to use function and because it's one of the first power functions that they get to learn for Excel. And others, perhaps more experienced users, think it's evil because we'll see what all the bad things about it are. Offset gets a bad press because it's a volatile function. I quite like it because it's very fast, and for some tasks it's really the best function you can use. Some product divides opinion. It's very powerful, but it can be rather slow. IndexMatch is by far and away the winner for the most heroic function, particularly amongst more expert users, and SumIfs gets some good votes. Now, so what we're going to do is look at all these functions in turn and see what the good points and the bad points are for each of the functions, and what, if anything, you can do as alternatives that might be better. Let's start by looking at get pivot data. Get pivot data gets you the data from a cell in your pivot table. The only problem with it is it's got a lot of incomprehensible parameters. Look at that lot up there. I mean, wow. Good news is it works when the pivot changes shape because it's got all these labels and stuff, so it just dynamically does a search. It gets generated by default when you click in the pivot. But of course there's a lot of bad news about it. It's hard to understand. The cell you're referencing's got to be there visible. You can't drag it around the place and get a collection of cells. It's single-threaded, so it's very slow. And it's a lot of people hate it when you click in the pivot and this incomprehensible thing gets generated. So, not wonderful. What are we going to do about it? Well, first thing I tend to do is to switch off auto-generation. So if we look down here, we can see in Excel options, you just uncheck that box there. And then when you click in it, it's not going to auto-generate. But really, if you're using get pivot data, that's because you've got a pivot table stuck in the middle of your chain of calculations. And I think that's, generally speaking, a bad approach. It's better to redesign things so you don't try and use a pivot table as an intermediate thing in your calculations. It's fine if you're using a pivot table as the final report. It's better to redesign it if it's part of the chain, use SUMIFs or VBA or dynamic arrays or something like that. Now, let's move on to what I think is the most evil function in Excel, indirect. Yeah. Now, it is a powerful function. There is no question about that. Here we're using VLOOKUP to look in a cell to determine which workbook we're going to pick, which worksheet we're going to use to pick up results from. Because I've got 3 sheets with some data on 2017, 2018, and 2019. When I change the year, it's in a little indirect pull down here, the data changes. And so we're using indirect of that cell, the year, which is the sheet name, and the range, and then we're looking up the values for each month. So, I mean, that's quite nice. It's very powerful. We've got a dynamic choice of worksheet, one sheet for each year here. We can handle tables in data validation using indirect, although it's better to use range references. So, what's evil about it? Well, it's slow. It's really slow. It's volatile and it's single-threaded. And if you make a mistake and refer to something which doesn't exist in your indirect, it wastes an awful lot of time wandering around your file system trying to find it on your PC. External workbooks that are referenced must be open. There's no adjustment when you add or delete rows, columns, cells. It's difficult to debug. The Excel's rather poor trace precedence command doesn't work with it. So what can we do about it? Well, you can't always do something about indirect. There are some cases where you have to use it. But wherever possible, I would use choose or offset or a VBA solution instead. So let's look at one of those. We'll look at choose first. Choose is one of my favorite functions. It's fast, it's non-volatile, it's multi-threaded, it's more robust than indirect, and it's pretty powerful. So to do exactly the same thing as we did with the indirect, we can use a choose function where we choose using match on the year into the years table to get a number, and then that number returns a particular worksheet table. So if we change that to 2019, bing, all the numbers change. Magic. The limitation, of course, is that you can only handle a certain number of choices before the formula gets very unwieldy. And you have to create all the choices in advance, which can be a good thing. You can do the same thing in a dynamic array version using, here we've got a transpose, choose, match, to get through to the answers. Okay, let's look at offset. Syntax for offset works like this. You have an anchor reference, that's the point that we're starting from. Then you have the number of rows you want to move down or up from that anchor reference, number of columns you want to move, and finally the number of rows that you want to return and the number of columns that you want to return. Offset's frequently used in dynamic range names and in moving averages. So here's a couple of examples. This dynamic range name, cells 2119, is defined as the offset from A4 on sheet 2019. There's 0 for row offset, 0 for column offset. The number of rows that we're going to use to return is delivered by a count A statement. So as the number of rows changes, as the amount of data changes on that sheet, the number of rows returned will also change. And finally, we're going to return 2 cells. So that gives us that. For a variable period moving average, we want to define the start period and the number of periods that in the moving average, and then finally we want to calculate the average of that. So let's change that to 4. And you can see here that the number of periods that we're picking up has changed to 4 from 3, and that the average actually changed. This formula is the offset that does all the work. So we're picking up the first how far off the start of the period we want to start, and so that's the B10, that's the row offset, and then this is the number of rows, n rows, that we want to return, 4 in this case. And then we just wrap it in inside an average to give us a variable period moving average. So what's good about offset is that it's fast and it's very convenient for things like the moving average. It is volatile, which is not good. It doesn't do any check on the bounds, so you can give it a really silly number and offset way off to the right or left or up or down. And it can be difficult to audit because, again, the trace precedence tool doesn't really work. So what are we going to do about all this? Well, if we're using dynamic range names using offset, there are some better solutions. We can use tables, which dynamically expand and contract as you add data. And we can do index-based range names using a formula like this. These are only semi-volatile. They're volatile at workbook open, but not during the rest of the time. And of course, Office 365 dynamic arrays give us a great solution to dynamic ranges. Sum product is some people's favorite function. It works quite well when you've got multiple logical conditions and you want to just add up the result of a data set applying these multiple conditions. Here we can see that we're looking up A4 to A1311, seeing whether it's equal to H4, which is the from country AT. So we use the minus to convert the logical answer true false out of that comparison to a number. We do the same for all the individual conditions, and we can build up little formulas in the middle, and then we sum all the answers of these times the actual values that we want to. So we get a whole series of zeros and ones multiplied together. If they're all true, we get a 1, so we multiply the 1 by the value from F4 to 1311. So it's good to use for multiple conditions. It's kind of, you can see that laid out quite nicely. It's easy to use, it's flexible because you can build things up nice and easily, and you can put intermediate calculations in the middle. It's a bit slow, and it's drastically slow if you start using full column references, because then you're multiplying millions and millions of rows together. With Excel 365, you can do the same thing using the new filter function. It's not actually any faster than sum product. It's very, very slightly faster. but it's in some ways it's much easier to work with. Now, a better way, in my opinion, of doing a lot of this is to use SUMIFs and COUNTIFs where you can. So we'll look at that next. So here's a SUMIFs example doing exactly the same thing as the sum product that we just looked at. The good news is it's much faster than sum product. It does handle whole column references very well. And sometimes you can get away with doing good things with SUMIFs because you can use wildcard criteria for the text. On the other hand, it's got some problems. It doesn't really distinguish text from numbers very well, and you can't embed functions within the criteria range, so it's not as flexible as sum product. Now we're going to look at 3 lookup functions: VLOOKUP, IndexMatch, and XLookup. There's probably been more time spent arguing about the pros and cons and relative merits of VLOOKUP than IndexMatch than I care to think about. However, let's go through some of the pluses and minuses of these functions. We'll start with VLOOKUP. VLOOKUP is a very simple function. It's easy to use. We've got a value we want to look up. We've got a lookup table that we want to find things in, and we tell it which column from the table we want to return the values from. And then there's an argument on the end that says whether the data is sorted or not. Okay, this all seems very straightforward. What's the problem? Well, it's really evil because the default is to assume that the data is sorted, and 99% of the time the data is not sorted, and in that case it gives the wrong answer. So we look up 9 using that default, and it gives us the answer 40. What? The answer should be 90. So very rarely use VLOOKUP using the defaults. Not a good idea. The other problem is that even if the data is sorted like this table here, when you try to look up a value that doesn't exist in the table, for instance, I'm looking up the value 3, doesn't exist in the column I'm looking up, the look at column, it gives me the wrong answer. It gives you the value which is less than the value. So it's returning that 10 there because the 1 is less than 4. Other evil things about VLOOKUP, it's inflexible. You always have to look up the first column, and you give it a column number to say what you want to return from the lookup table. And of course that breaks when you insert something, column in the middle. The column number is now referring to a different column. And it's pretty slow with exact match, which is what you want to use most of the time, because it starts at the beginning of the data, says, does that give me the right answer? No. Let's look at the next row. Does that give me the right answer? No. And so on. So if you've got 100,000 rows, that takes a long time. In Office 365, they've speeded that up quite a lot, which is great for those of us who have Office 365. Now, there is a magic trick you can do when your data is sorted to handle the case when you're looking for something and you don't know whether it exists or not. This is the case when we're trying to find 3 in this table sorted here. We want to use the sorted option of VLOOKUP because that's very fast. So, step 1, we say, can VLOOKUP find 3 in lookat? So we do a lookup of 3 in A11 to B15, 1. That should return 3 if it's there. Okay. Step 2. Well, if it does equal the value we're looking up, then we do the lookup to get the return value. Otherwise, we're shown an error message. So, does VLOOKUP of that equal 3? If VLOOKUP D19, A11 to B15, 1 equals D19, we're good. It does exist. So we'll do the right lookup and return the answer from column 2, which is what we want. But if it doesn't equal the value we're trying to look up, then hey, that data's not there. So we'll return an error. In this case, I just chose to use the text missing. Now, we've got to do 2 lookups instead of 1 when the data doesn't exist in this case, but that's still much faster than using an exact match once you've got the data sorted. And in fact, sorting data in Excel is incredibly fast, so that's often a very good solution. So what's good about VLOOKUP? Well, it's very fast with sorted data. It's a lot simpler than IndexMatch. It's a nice, easy function to use. And again, you can do wildcard searches with it, which is good if you've got textual values. However, the evil points usually outweigh the good points, so I recommend using IndexMatch instead. And if you're lucky enough to be on Excel 365, you can use a new function, XLookup, which we'll look at in a minute. Okay, so now IndexMatch. So what we're going to do is we're going to index through a table, and then we're going to find the row number that we want to return the value from and the column number that we want to return the value from. So in this case, we're doing a sort of two-way lookup. We're looking up both something in the rows and something in the columns. So what's evil about IndexMatch? Well, again, same old problem as with VLOOKUP. The defaults give you the wrong answer. And when the data is sorted, you get the wrong answer for missing data. Now, you can use a double match trick in the same way as we use double VLOOKUP trick, and that will work. Exact match, of course, is slow with large data in the same way as it was with VLOOKUP, and again, that's faster in Office 365. Now, it's more complex to write IndexMatch functions than it is VLOOKUP, so that's a drawback. On the other hand, there's lots of good points. It's flexible. You can look up any column you like and return any column you like. You can handle matching both rows and columns as in the example above, and that's going to avoid breaking things when somebody inserts a column in the middle. It's very fast with sorted data like VLOOKUP. And the other good thing is frequently you want to return multiple values from a table, multiple columns. So you can use match once and store the result somewhere, and then use index lots of times, looking up that value. So that's very fast because you've done the match once, and index on its own, when you just give it a row number and a column number, is very fast. So that works well. And the other good thing about IndexMatch is you get hash ref if you try and return a value that's not inside the table. So it's nice. Some people say it's faster than VLOOKUP. It is faster if you can do the match once, use many times trick. But otherwise, for pure like-for-like comparisons, index and VLOOKUP, there really isn't anything much in it. My tests show that VLOOKUP is very slightly faster because there's only one function as opposed to two. But in any case, the difference is, less than 10%. So you're never actually going to notice the difference in speed performance unless you can do the use match once and then use it many times in the index statements. And that's a great solution. So finally, let's look at the new kid on the block, XLookup, only available in Excel 365. Finally, we've been asking Excel team to do something about the horrible problems inherent in VLOOKUP and IndexMatch for many years. And great, it's arrived and it's good. So let's look at the syntax. You have XLookup, so then the value you want to look up, in fact, with XLookup, you can look up multiple values. Usually it's only going to be one. You tell it what column you want to do the lookup in. You tell it what column you want to return the answer from. In fact, this can actually be multiple columns as well. you've got a value you can give it if it's not found. Yay! And you've got a match mode, which can be, start at the beginning and look forward, start at the end and look backwards. The data is sorted, find the data is not sorted, but still find the nearest match, stuff like that. Now, let's look at the good points. Hey, the defaults give you the right answer. Wow! It's flexible. I can look up any column I like. I've got separate lookup columns and return columns, so nothing breaks when I insert columns. And I'm actually, no, we're not going to talk about that. It's fast because it embodies all the speed ups that they put into VLOOKUP. You've got a return value you can give when nothing matches if not found. You can return multiple columns. You can return multiple rows. You can search backwards, you can search forward, and rather subtle point, XLookup actually returns a range rather than the value, which we can do clever things with. So let's look up multiple columns. XLookup A15, A4 to A8, B4 to C8. So I'm returning data from both column B and column C. So that gives me both 90 and Liam. It's returning those two columns because the value I told it to look up was 9. If I give it two values to look up for the rows, then like both the 9 and the 4, it will return the values that match those. So the 9 matches 90 and the 4 matches 40. Notice that it's returned the value for 9 first and the value for 4 afterwards, even though it comes before it in the table. And it still does that efficiently. Magic stuff. Returning a range is really rather clever stuff. Suppose we want to sum all the values between two lookup values. So we can do that by, we look up the first value using one XLookup statement. Then we have a colon, which is the range operator. And then we have the second XLookup statement. And we wrap all that in a sum. So this thing is looking up the values 9 and 4. And it's returning the sum of the values between those, which is 40 plus 60, 600 plus 90, 730. Here's an example of using the not found optional argument. So we look up a value which 5, which doesn't exist in there. Hey, we get not found without doing the double lookup trick or anything nasty like that. We can find the next smallest using the search mode argument. And of course you can find the next largest as well. You can find both the row and the column using two XLookups like this. And so it's a really great function. The only bad news is it's only available in Office 365. Well, I'm out of time, so thank you all for joining me in this session. And I hope you enjoyed it and learnt one or two things about Excel's evil and hero functions. Bye.